Welcome back to AI Explained. For those just tuning into AI Explained for the first time, we like to do a deep dive every episode.
Okay.
And today we're going to be taking a look at world foundation models.
Okay.
It's a pretty exciting topic. And,
Yeah.
I think this is something that has the potential to really revolutionize the way that we think about interacting with the physical world.
Yeah, it's very interesting because it's moving beyond AI that just understands language into an AI that can predict the physical world.
And when I first heard about this whole concept of world foundation models,
Yeah.
I was like, whoa,
Yeah.
what is this? Is this going to be like some sort of system that can predict the weather or the stock market, like something out of science fiction?
We're not quite there with predicting the stock market just yet,
Uh-huh.
but these foundation models, or WFMs as we like to call them, are really revolutionizing a lot of industries, particularly robotics and autonomous vehicles.
So the thing that really prompted this deep dive today was Nvidia's announcement of Cosmos, which is this platform for open source WFMs. And they're trained on a massive amount of data.
Yeah. We're talking like 9,000 trillion tokens from 20 million hours of real-world data. Like, are you kidding me?
It's quite impressive.
That's insane.
The thing that's really impressive about this data, though, is the diversity of it.
Right.
It's everything from human interactions to industrial settings to robotics to driving data.
Okay, so, for our listeners out there who are like, what is a World Foundation model? Can you explain that?
Sure. So basically, a world foundation model is a neural network that can predict and generate future videos.
Okay.
But the videos that it generates are physics aware, so they actually reflect how things would actually unfold in the real world.
So it's not just like, a bunch of random things happening or recognizing a pattern. It's actually like understanding like the rules of the game
Exactly.
and
Yeah.
using that to predict. That's what makes
yeah.
it different. Exactly.
Yeah.
So previously with AI models, you could generate videos, but they didn't really adhere to the laws of physics. So like a ball might float upwards or a car might turn without slowing down. But in this case, the WFMs are trained on such a massive amount of real-world physics data that they can understand how objects will move and interact with each other.
So it's like they understand how things actually behave, not just what they look like.
Exactly.
There's a big difference, right?
It is a big difference.
So, it kind of makes me think about large language models like ChatGPT.
Right.
Which can generate human quality text. Is this kind of like the same kind of thing, but for the physical world?
It is. It's very similar. Like
Oh.
just how LLMs have revolutionized how we interact with language. These WFMs are really revolutionizing how we interact with the physical world.
So what are some of the applications of this? What are some of the real world applications where we're going to see this have the biggest impact?
So I think the biggest impacts are going to be in robotics and autonomous vehicles.
Okay, so what specifically? So for robotics, for example.
So for robotics, imagine a robot that can not only navigate its environment, but it can predict how objects are going to move and interact with each other. So it can actually start performing tasks at a level we've never seen before.
So it's like giving robots a sixth sense.
Yes.
They can kind of intuit the world around them.
Exactly.
And for AVs.
So for AVs, think about the challenges that we have with self-driving cars right now. One of the biggest challenges is really being able to anticipate and respond to human drivers and pedestrians.
Let's face it, humans are not predictable.
Exactly. And so with these WFMs, they could potentially predict how other vehicles are going to move pedestrians, cyclists, animals.
It's like giving them the ability to read minds in a way.
Yes.
Not literally, but just to be able to see those subtle cues and be like, okay, I know what's about to happen. That's wild. And what's really cool about this is that Nvidia is making these WFMs open source.
Yeah.
So they're available through their platform Cosmos.
Yeah.
And so this is really going to democratize access to this technology.
Yeah, it really is.
What's the significance of that?
The significance is that now researchers, developers from all different backgrounds can now utilize this technology.
So it levels the playing field.
It does.
And it's not just about making the WFMs available. It's also about providing tools to actually use these things, right?
Right, exactly. Cosmos also provides a lot of tools to fine-tune and customize these WFMs, so you can adapt them for very specific tasks and applications.
Oh, wow. So it's like they're giving you the base, and then you can go and you can tweak it and make it your own.
Exactly. You can think of it as a toolbox that really empowers you to mold these WFMs to your needs.
That's really cool. So are there any examples of real-world companies that are already using these WFMs?
Right. There are. So there are a couple of companies already pushing the boundaries of what's possible with WFMs. One company is Waabi. and they're an autonomous vehicle company, and they're using WFMs to search and curate video data.
Hmm.
And they're using it to make sure that their AI is trained on really the best and most diverse examples possible.
So it's like an AI assistant for data, basically.
Exactly. And this is just one example, and we'll
Okay.
get into more of these real-world applications after the break. And they're also using Cosmos to enhance their AV simulator, which is called Wabi World.
Oh, okay, cool.
Wabi World is really interesting because it's basically a virtual proving ground for AVs where they can test and refine their systems in this really controlled environment.
So rather than having like a self-driving car,
Yeah,
out in the real world bumping into stuff, they could do it virtually
exactly.
where they have, a lot more control.
Exactly. And by integrating Cosmos into Wabi World, they can create these really challenging and realistic scenarios for their systems.
Okay, yeah, that makes sense.
Right.
So the more challenging it is in the simulator, then the more prepared it's going to be when it actually gets out into the real world.
Exactly. And this is just one example of how companies are starting to leverage WFMs.
Okay.
Another company that I wanted to talk about is Hillbot, and they are using Cosmos in a completely different way to develop embodied AI.
Embodied AI. What's that?
So embodied AI is basically AI systems that are embedded in a physical body like a robot.
Okay.
And Hillbot is using Cosmos to create these virtual environments for their robots to train in.
Oh, so instead of having to train the robots like in real life, they're training them in a simulation.
Exactly.
That's awesome.
And because these virtual environments are generated by WFMs, they're incredibly realistic, and it allows them to basically train their robots on a much wider range of scenarios than they would ever be able to in the real world.
So it's like boot camp for robots.
Exactly.
But it's like virtual boot camp. So
Yeah.
it's like, they get exposed to all of these different like crazy situations. And that way, when they actually get out into the real world, they're not like, surprised by anything.
Exactly. And the applications of WFMs go even beyond robotics and autonomous vehicles.
Okay.
We're seeing WFMs being used for things like synthetic data generation as well, which has huge implications for things like healthcare or manufacturing.
Synthetic data. So it's like making up data.
Well, not exactly.
Yeah.
So instead of relying solely on real-world data, which can be hard to come by and very expensive to collect,
Right.
you can use WFMs to generate these massive data sets that are really realistic.
Okay, so for example, like a pharmaceutical company could use WFMs to generate data of like patients
Exactly.
to train their AI models to maybe like, come up with new drug candidates or something like it.
Exactly. Or a manufacturing company could use WFMs to simulate all these different production scenarios to try to figure out how to optimize their processes.
So it's like having a data factory
Exactly.
where you could just create whatever data you need to train your AI.
And we're also seeing a lot of exciting development in the area of advanced simulation.
Okay.
Remember how we talked about Wabi World earlier?
Yeah.
That's just one example of how WFMs can be used to create these really realistic virtual environments.
Okay.
And so instead of having to physically build and test prototypes, which can be really expensive and time-consuming, you can use WFMs to create virtual prototypes.
And run a bunch of simulations.
Run countless simulations, exactly.
Oh, that's awesome. So what are some of the applications of that?
This has huge implications for things like aerospace architecture, urban planning.
So you can like design like an entire city in a simulation
Exactly.
before you actually go and build.
Before you break ground.
Yeah.
Yeah.
Oh my gosh. That's wild. And it's all based on like real world physics.
Right. It's not just pretty pictures. The
Mhm.
simulations actually provide really valuable insight that can be used to make decisions in all these different industries.
Okay, so it's like having this like digital twin of the real world
Exactly.
where you can kind of like play around with different scenarios.
And that brings us to another application, which is accelerated reinforcement learning.
What's that?
So you're familiar with reinforcement learning, right?
Yeah, like when an AI learns through trial and error, like you train a pet to do a trick.
Exactly. But in this case, it's a little bit more complex than that. So imagine an AI agent learning to play a video game.
Okay.
And it's playing the video game over and over and over again. And through all of that trial and error, it's getting feedback and it's learning how to play the game more effectively.
So it's like giving the AI agent like thousands of lifetimes to learn.
Exactly. And that's where WFMs come in. Because by creating these incredibly realistic virtual environments, they can actually learn and adapt much faster than they could in the real world.
So they're speeding up the process.
Exactly.
Oh, wow. That's awesome.
And this has implications for all sorts of things like optimizing traffic flow to developing new medical treatments.
Yeah, you're basically taking that AI training process and putting it on fast forward
Exactly.
so you can get to those solutions much faster.
Exactly. And it's all thanks to the power of world foundation models.
I mean, it's kind of crazy to think about like all of the things that we could potentially do with this technology, from robotics to AVs to healthcare to like redesigning cities. I mean, it really feels like we're on the cusp of something huge here.
It really does. It feels like the pace of innovation is just accelerating.
Yeah.
Yeah.
But, with any kind of new technology, especially something this powerful, like we have to be careful, right?
Right.
We have to think about the potential downsides.
Absolutely.
These are systems that are learning to predict the future, and that comes with a lot of responsibility.
Yeah. And as these systems become more sophisticated, it's really important that we focus on transparency and accountability.
Yeah, like how are these systems actually making decisions?
Right.
And are those decisions aligned with our values as humans?
Exactly. It's like teaching a kid how to ride a bike. You don't just give them the bike and say, go ride.
Right.
You have to teach them the rules of the road.
You got to make sure they know how to be safe.
Exactly. And it's the same thing with AI.
Yeah.
We need to give these systems clear guidelines and make sure that they're being used in a way that benefits everyone.
So it's not just about like, developing the technology for the sake of technology.
Right.
It's about doing it in a way that's ethical and responsible.
Absolutely.
And that's going to require a lot of collaboration between a lot of different people.
It will. Researchers, developers, policymakers, the public.
Yeah, we need to all be on the same page
We do.
and having these conversations about like what are the potential impacts of this technology
Right.
and how do we make sure that it's used for good.
Absolutely.
So it sounds like WFMs have the potential to be an incredible force for positive change in the world.
I think so.
But it's really up to us to guide their development and make sure that, we use them in a way that benefits humanity.
I agree. The future of AI is not set in stone. It's something that we're all creating together.
I love that. So I guess the main takeaway here is that like we're on this amazing journey with AI and WFMs are a really big part of that.
They are.
And it's going to be really exciting to see what happens next.
I'm excited to see what the future holds.
Well, hey, I want to thank you for joining me on this deep dive into WFMs.
Yeah, it's been fun.
I hope you learned something new today. And be sure to subscribe to the channel for more AI Explained.